Hello, welcome back to the channel, and today we're starting a new series looking at shapes, and this series will cover topics that appear in Key Stage 3 maths. So Key Stage 3 is part of the UK syllabus and is aimed at ages 12 and 13-year-olds, all the way through GCSE. We're going to be covering A-Level, and we will also cover some things that you might come across in university if you do physics or maths or engineering there. So we're going to start this series off by looking at circles. So circles are a two-dimensional shape, or 2D shape, with one continuous side, and all points on that side are equal distance from the centre. So a circle has a number of properties. It has a circumference, which we'll call C, which is the distance around the outside, so it's effectively the perimeter of the circle. We have the diameter, which in this case we're going to be using green, which is the furthest distance from one edge of the circle to another edge, and for it to be the furthest distance, that line will have to go through the centre. So it's a line that connects any two parts of the circle via going through the centre, and we call that D. We also have the radius, which is R, which is the distance from the edge of the circle to the centre of the circle, and we're using red. And then we also have the area, which is A, which is the property that's enclosed by the circle. So let's start off with just relating the radius and the diameter. So since the diameter is the full distance across the circle, and the radius is any distance from the centre to the edge, it means that the diameter is equal to 2 times the radius. So that's the first thing we can observe from circles. Next up, let's look at the circumference. So, when we are dealing with circles, we come across a number called pi, which is given the Greek letter pi, which is 3.141, and then this is an irrational number, so it keeps on going on and on and on without repeating. So pi is the number which relates the circumference of the circle. It's actually the ratio of the circumference to the diameter, which means that the circumference, if we rearrange this, so when we talk about the ratio of the circumference to the diameter, we mean circumference divided by the diameter. If we take this d up to the other side, is equal to pi times d. And we can replace that d, if we wish, with r, so we can have 2 pi r. So this is the formula that allows you to find the circumference of a circle if you know either the diameter or the radius. Obviously, if you do know the radius, you should be able to know the diameter, and if you know the diameter, you should know the radius as well, or be able to calculate the radius. So now what we're going to look at is the area of the circle. So if you're in a high school situation, they tell you the area of the circle is equal to pi r squared, and they just tell you to memorise this. So if you want to find the area of a circle, you multiply pi by the radius and then you times it by the radius again. So r times r is r squared. So if you can remember that formula, that's great. If you're happy with that, again, that's great. However, one thing I found with my tutoring, because I do private tutoring, is that many students I have are either struggling with maths or are gifted in maths and want to push themselves further with it. And this is one of the problems with the education system, is that you're just told to accept it, and you're not told any reasons for it or why it's applicable. So when I tutor, I teach understanding. So what we're going to do is understand where this formula comes from, so you don't get that frustration. It also gives, when you actually try to understand something, it gives you the ideas of critical thinking and exploratory thinking, and therefore it's useful for later life, especially if you go to university and you want to study science or do anything else which requires you to analyse and think about things. So let's prove where this comes from. So I'm going to start off with just writing it here so we can keep an eye on it. So it's pi r squared. So that's what we're hoping to come back from. So let's think about this circle. And let's say we take a radius from this circle, so let's put that radius back in, and then we draw another radius. What we have here is a section of the circle. Let's say we keep doing these radiuses and we space them equal distances around the circumference. So in this case, let's say there were 4 of them. If we take this idea now, this circle, and we unfold it, so we straighten out the edge, so we have a straight line, and this straight line will have a length which is equal to the circumference of the circle, which was c, which was 2 pi r. And on top of this, we're going to have 4 equal triangles. And the sides of this triangle, this is going to have side r, this will be side r, this will be side r, and so on. And we've also got this side at the bottom here, which in this case will be 2 pi r divided by 4, because there are 4 triangles. So they're going to be isosceles triangles with 2 sides of r and 2 sides of pi r over 2. When we can now try and calculate the area of these triangles, so we have to find the vertical. However, what we can do is a little trick here. So let's imagine we divided this circle now into an infinite number of triangles. So we still have our 2 pi r along the bottom, but now we're going to have very thin triangles, which are basically going to end up looking like a load of very close together spikes, all of radius r. And when's the so this distance along the let's try and explain this in a better way. Each of these we now have n number of triangles. So let's let n equal the number of triangles we had. So in this case, n was equal to 4. So each triangle, let's draw it out. We'll have r here, and this bit along the bottom will be 2 pi r over n. If n is sufficiently big that this distance across the bottom is very small, r it tends towards the height. So if n tends to infinity, r will tend towards the height. And now we can actually calculate the area of this triangle. So the area of the triangles, let's call it a tri, is equal to half the base, which is 2 pi r all over n times the height, which is another r. So we can simplify this now to be equal to, I'm just making sure I've got enough room on the board, is equal to this 2 and this 2 are going to cancel. Pi r squared over n. However, when we've unwrapped the circle, we now have n triangles. So if we now go back to the blue pen, the area of the circle, so let's write that here, this pen is running out, so I'm going to have to go with black instead. The area of the circle, so let's call it area circle, is equal to the area of the triangle multiplied by n, which is equal to pi r squared over n multiplied by n, so these n's cancel out, which is equal to pi r squared, which is where we come back from. So this is where the area of a circle comes from. You can imagine it being divided into triangles and then calculating the area of each triangle, multiplying by how many triangles you have, and you end up going through to this. And if you take this assumption where the number of triangles is very large, so the radius of the triangle becomes the height, then it makes the maths a little bit simpler. So this takes us back to this formula. So sometimes when you have area questions revolving around circles, sometimes you'll be asked to find a section of a circle. So let's say you had a section of a circle which has an angle of, let's call it theta degrees, and you wanted to find, let's say, the circumference, the arc. So a section of the circumference is called an arc. So let's calculate the arc here. So this distance here is called the arc. So let's say you want to find the arc of this. The way we do this, and let's say this is r, so we're coming from the centre of the circle and this is the radius. The arc length is going to be equal to the whole circumference, which was 2 pi r, but we only need to take a fraction of it. And a circle, the whole circle in the middle, is equal to 360 degrees. So if we find the ratio of this angle to the 360, we end up with theta over 360 degrees. And this is if we're working in degrees. When you get to A-level, you learn about radians, in which case the angle theta will be measured in radians. Instead of using 360, you use 2 pi instead. And if you notice then, the 2 pi will cancel out here, so you end up with just r theta if you're using radians. So we will talk about radians in another video, but that's a preview of what to come. Now let's say we want to work out the area of this section. So let's call this area, and let's just define the section by drawing the shape in. We can do exactly the same trick we've used. We use the formula for area of the circle, which is pi r squared, and now we need that fraction of the circle that we have, which is theta over 360 degrees. And again, for the A-level students, if you're doing this in radians, you end up with the 360 being replaced with 2 pi, so the pi will cancel, so you end up with 2 r squared theta is equal to your area of this section. So those are the areas and circumference and sections of area and circumference, or the arc, of circles. Obviously these can be used in everyday life. If you ever have to calculate the area of a shape, you might need to calculate the area of a size of cake. It comes in useful in a number of ways. Anyway, in the next video we will look at four-sided shapes, so squares and parallelograms. So hopefully you can join me for that.